Have you ever looked up at a skyscraper and wondered, how on earth did they build that? It's not just about stacking floors higher and higher. Today, we read diving deep into the incredible engineering and groundbreaking architecture behind the 10 biggest buildings on the planet. This is the story of how humanity reached for the sky and revolutionized the way we live and work. So what does it take to build a giant? It starts with the skeleton. Modern megastructures rely on advanced steel alloys that possess unparalleled tensile strength. Think of it like a super strong backbone, allowing buildings to soar to incredible heights while remaining flexible enough to sway safely in high winds. Without these custom-made materials, giants like the Burj Khalifa would simply be impossible. But a strong skeleton isn't enough. These buildings have to be smart and sustainable. The skin of these giants, their facade, is an engineering marvel in itself. It's not just glass and steel. It's an optimized system designed for thermal performance. Special coatings and double-glazed panels keep the heat out in the summer and the warmth in during the winter, drastically cutting down on energy costs. Creating brighter, more pleasant spaces inside and reducing the need for artificial lighting. Speaking of keeping things comfortable, let's talk about the lungs of these buildings. The HVAC systems. That's heating, ventilation, and air conditioning. In a building with thousands of occupants, climate control is a monumental challenge. The world's biggest buildings use advanced, hyper-efficient HVAC systems that are finely tuned to the building's needs. They use smart sensors and predictive analytics to deliver conditioned air exactly where it's needed, minimizing waste and ensuring every corner of the building remains comfortable, no matter the weather outside. The commitment to sustainability goes even deeper, right down to the very materials used in construction. There's a huge emphasis on using sustainable, recycled, and locally sourced materials whenever possible. This not only reduces the carbon footprint associated with transporting materials over long distances but also supports local economies and promotes a circular economy where waste is minimized and resources are reused. From recycled steel to sustainably harvested wood, every choice matters. Now for the really cool part, how these giants power themselves. Many of the world's tallest buildings are becoming self-sufficient power plants by integrating renewable energy sources directly into their design. One of the most visually stunning methods is building integrated photovoltaics, or BIPV. Instead of just slapping solar panels on the roof, the solar cells are built directly into the glass of the building's facade. The windows themselves generate electricity while still allowing light to pass through. It's a seamless fusion of architecture and energy production. Of course, you'll also find massive rooftop solar arrays on many of these skyscrapers. These large-scale installations are dedicated powerhouses, capturing sunlight and converting it into electricity to power the building's extensive operations. By utilizing the vast unused space on their roofs, these buildings can generate a significant portion of their own clean energy. But what about when the sun isn't shining? That's where wind comes in. High up in the sky where these buildings touch the clouds, the wind is a powerful and consistent resource. That's why architects are increasingly integrating vertical axis wind turbines, or VAWTs, into the upper levels of their designs. Unlike the traditional propeller-style turbines you see in fields, these vertical turbines are perfectly suited for urban environments. One of their biggest advantages is their ability to capture wind from any direction. In a city, wind patterns are complex and unpredictable, swirling around buildings. VAWTs can harness this chaotic energy effectively. Plus, the higher you go, the better the wind. At several hundred meters up, wind speeds increase dramatically due to a phenomenon called wind shear. There's less friction from the ground and other buildings, meaning the air flows faster and smoother. This smooth, less turbulent airflow at high altitudes is a massive benefit. The constant buffeting of turbulent air can put a lot of stress on turbine components, causing wear and tear. Smoother air reduces these fatigue loads, extending the lifespan of the turbines. It also makes energy production more predictable and efficient. And for the people living and working inside, VAWTs are a great choice because they operate much more quietly and produce fewer vibrations than their horizontal counterparts. It's a win-win for energy generation and occupant comfort. From their super strong steel skeletons and smart glass skins to their integrated solar panels and high-altitude wind turbines, the world's 10 biggest buildings are more than just towering structures. They are living, breathing ecosystems, pushing the boundaries of what's possible in sustainable design and engineering. They show us a future where our cities can be smarter, greener, and more awe-inspiring than ever before. Thanks so much for joining us on this architectural journey. If you enjoyed this look into the future of construction, don't forget to like, subscribe, and hit that notification bell so you won't miss our next deep dive. See you in the next video.